Now we're going to take a look at difference of squares that aren't just written as a square. So these are squares because there's something that gets squared that becomes this number. 36 kind of stands out as 6 squared, I hope. But x to the 6th, usually students look at that and we're like, well, that's not a square, it's a 6th. Yeah, but something squared can give you an x to the 6th power. And the thing that gets squared is x to the 3rd. And how I do that quickly is all you have to do is see something even. If it's even, you can rewrite it as a square because the way powers work, when you raise a power to a power, you multiply the powers. And that's where the 6 came from. So all we have to do is recognize if it's an even power, it can be written as a square. And then you need a different sign to actually have it be a difference of squares. So the idea here is that this is really an a value squared, a 6x cubed. The whole quantity squared is my a that's being squared. Minus the b that's being squared is just 1. So this is minus 1 squared. All we have to do is recognize the a and the b. And the pattern says I just write my a value, 6x cubed, and then the b value, 1, in 2 separate parentheses, 6x cubed and 1. And then all you have to do is put a plus sign in one of the parentheses and a minus sign in the other set so that we have conjugates. And this product of conjugates is the factored form of my original polynomial, fully factored using the difference of squares. Now, I said fully factored, and that was a quick jump. You have to be careful because if you end up with another even power on and another square over here on the one that has a difference, so it's like big star, pay attention right here on the difference parentheses, sometimes this will further factor, which we are going to run into in subsequent examples. All right, in this example, we've got 2 variables. So the 49, hopefully that just kind of jumps out as a 7 squared minus, and then the question is x to the 4th, y to the 4th a square? And yes, it is because both powers are even. So all you're looking for is even exponents. If they're even, they're squares. Now, squares mean that something squared gives me that value. So what I'm looking for is what can I square that will give me x to the 4th, y to the 4th. And all you have to do is divide these by 2 to get there. So if I divide it by 2, I'm just doing the inverse operation of what squaring it would be. And that is x to the 2nd, y to the 2nd. If I took x squared, y squared, and squared it, this 2 distributes, and you would get x to the 4th, y to the 4th. And so that's demonstrating that x to the 4th, y to the 4th is a square. It's x squared, y squared, squared. So all of that to say, this is your a value, this being the 7, and this is your b value, that's this whole x squared, y squared. So our factoring technique with difference of squares is just you set up 2 parentheses, you write the a and then the b, x squared, y squared, in both parentheses. So 7, x squared, y squared. And then in the first, you put well, it doesn't matter which one gets the plus or the minus, but you put a plus sign and a minus sign, and you're done. The whole key is identifying what are the squares. What squared gives you the first term, and what squared gives you the second term, so that you can just write them in 2 sets of parentheses, and then make them conjugates, 1 plus, 1 minus, and you're done. On this example, we have both terms have coefficient parts and variables that are even. So this is the difference of squares. We recognize the 49 as being 7 squared, but then that x to the 4th, it's even, so we just divide it by 2. Dividing 4 by 2 gives you 2, so it's x squared. So that we see 7x squared, if I wrote it twice and multiplied, or wrote 7x squared squared and distributed that square, you would see I'd get 49x to the 4. So this is indeed a square. So that's the first one squared, minus, and this one looks more like a square because it actually is squared. So minus what squared gives me 4 is 2, and then y squared is just y. the quantity squared. So what we have to be careful about is, notice I'm pulling this exponent out, so don't leave it on the y, but you recognize that 2y, the quantity, gets squared. That is my b value. This 7x squared is my a value. So I have a squared minus b squared. The formula says I write them in two separate parentheses as conjugates. So I have 7x squared plus 2y, and then 7x squared minus 2y. And that will be my difference of squares. Now, so far in all the examples, these last three, none of the second part has turned out to be a difference of squares. Subsequent problems, we will have more layers to unfold with this perfect square factoring, difference of squares factoring.